Hello guys, good day. Welcome back to my channel. And for today's video, I will be discussing about the Shear calculation by manual calculation and compare natin yung results sa ETABS software. And we have here a problem. So, design Shear computation. Ito yung geometry natin. And meron tayong cantilever para sa parapet natin. And we have here a data. Occupancy is the office. Then we have a different sizes of the slabs, beams, and columns. Pero ito kasi sa parapet, may parapet wall kasi siya. And may parapet beams. So I assume na meron tayo ditong beam. Ito. Napapatungan. Although, pwede naman yan sa actual na walang beam. Pero, assume na lang natin na meron siyang beam. Kasi meron siyang parapet beam dito eh. See? Okay. And we have here the loads. Sa roof and the floor loads. For the SDL and the live load. And for the seismic parameters, we have here the Z. And zone 4.4 and seismic source type A is A and soil type natin is AC, and of course the standard occupancy. The distance to seismic source is 10 kilometers. So type ano na talaga to, A, kasi it's 10 kilometers or more as per the code sa NCP, so A na siya. Then we will use the special reinforced concrete moment frame. And the requirement is the design base shear along the transverse direction of the building. And B is the lateral forces in its floor and transverse. Actually in ETABS, same lang, almost same lang kapag na yung mga result niya. Especially kung mga regular buildings. Anyway, we'll check the result. And we need to use the design code 2015 NCP. And make all the necessary assumptions needed. So, tayo na mag-assume. And start na tayo. Sa assumption natin, para sa unit weight ng concrete, we will use 25 kN per cubic meter. And for the mass source, include natin yung 25% ng live load. Although hindi naman siya necessary kasi hindi na specified dito, pero i-assume lang natin kasi may note naman dito na pwede na tayo mag-assume. Lahat ng necessary na dapat i-assume. Then, okay. So, before tayo makapag-create ng weight ng structure, kasi kailangan na yan eh. Ito yung pinakaunang dapat nating kunin, yung weight ng structure. So para makuha natin, of course, kailangan natin kunin manually. So I'm using this one. I'm used the MathCAD application. Mas madali siya. Tapos automatic siya, calculation. Na-calculate niya kagad. And makikita mo kagad yung mga ginamit ng variables, mga data. Yan. Okay naman din sa Excel, kaso nga lang naka-hide kasi yung mga formula. Although pwede siya ipakita natin, pero mas for me, MathCAD, mas maganda siya. So ang kailangan natin dito is beam. So para sa level 2, ang sinasabing level 2 weight na yan, ito. Kasi yung of course yung lateral force natin ganyan yan eh. So yung half nito, ito yung weight niya. Okay? Okay, ando ko lang. Okay, balik tayo. Sa beam, sabi natin WB2. As you can see, gamma times the volume lang yan ng lahat ng beam within that level. So, ang size natin dyan is ito. Sa level 2 na beam, 300 by 400. Kaya 300 by 400, multiply natin sa total length. Yun, shortcut ko na lang. Total length Sa level 2, as you can see, ito yung typical floor. So lahat ng biga na yan, yung perimeter natin, plus lang ninyo. So yung magiging perimeter natin is 189 meters. Then makakakuha tayo ng 567 kilonewton. Sa slab naman, 0.1 kasi yung thickness natin sa level 1. Ito, sa slab all floors. And sa slab naman natin, ito, hindi ko na pala consider or hindi ko binawas yung mga intersection nila. Okay. Then, pwede yan, pwede siya ma-assign dun sa ETABS na considering wala siyang, offset. Okay? So, bali center to center, para makuha natin yung total slab, ang ginawa natin dito, yung total, ito lang. Total nito, then, ito, multiply natin para makuha natin yung area. Pag makuha natin yung area, mayroon tayong thickness of volume na yan. Multiply natin sa unit weight ng concrete, kilonewton na siya. Then, yung ES2 naman, para sa floor loads. Ano lang yan? Yung loads natin in KPA, multiply lang natin sa floor area. So, yung floor area natin ito, which is nanggaling din yan dito, multiply lang natin, 317.52. And para makuha natin yung weight niya in terms of kilonewton, ang ginawa ko dito is DL plus 25% ng live load. Okay? Kaya ito. Yan. Then multiply natin yan, ito, by the area. Okay? And para sa column naman natin, yung nakita nyo kanina, kalahati ng ground floor. Pero calculate mo muna natin yung total height ng ground floor and the level 2. And pag dito na sa sum up, ang ginawa ko rito, kalahati ng ground floor and kalahati ng level 2. Yun ang kasama sa weight ng level 2 natin. So ito yung level 2 natin na weight. So same process ang gagamitin natin. Okay, ito yung level 3, level 4, and level 5, and of course the roof. Then kapag i-sum up natin yan, ito yung structure weight natin, 12,802.72 kilonewton. Yung calculated naman na sa ETABS, ito, 12,796.2. Kapag kunin natin yung variance, around 5% lang. So sa difference over the weight of the calculated value. So, sobrang late siya. And para makalculate natin yung structure period, ito ang kailangan natin, formula as per the code. So, yun. So, sa C natin, pag type C kasi, eto, mag-fall tayo dito. Pag soil type C, NA natin is 1.0, then NV is 1.2. Yung C naman, 0.4 NA, and CB natin is 0.56 NV. Check na lang niyo sa code sa NSCP. And our CP, it is in meter. Ito, nilagay ko na lang yan kasi itong units na to, dito pala sa MATCAD kasi kailangan mag-insert ng mga units para lang makuha mo yung exact units. Kasi automatic may units na siya Ang problema kasi dito kapag may mga coefficient, empirical coefficient like 0.0731, wala na, unitless naman siya, di ba? Pero nanggaling siya talaga sa may units. Kaya na-obtain natin yung CT. Ito, yung T na yan, nagiging seconds siya. So, ibig sabihin, yung CT na yan, may mayroong unit. Although hindi siya pinapakita, meron siyang unit. Kasi tingnan ninyo yung HN. Meter siya, pero yung nagiging result natin is in seconds, no? Anyway, kayo nang bahala mag-adjust yan. So yung T natin, using the 17.8 NH, the height of the building, 0.6335 seconds. Ayan. So, doon sa ETABS, same din. Same din yung ano. Kasi, ipapakita ko mamaya kung paano mag-setup. Anong setup ko doon. And sa design based shear naman sa manual calculation as per code, ito yung calculated CVI times W over RT. Yung is na yan, same. Nilagay ko na lang yan para makuha yung key-end. Kasi nga yung T, pati yung CV, yung I. So, yun. Kasi kapag hindi tayo mag-multiply ng S, hindi natin makukuha to. May empirical, ano kasi siya, coefficient. Nagmumula rito sa T. And the Vmax, it should be not more than with this calculated max Bisher. And we have a 2 minimum. Kailangan hindi siya lalampas dito sa dalawa. And ito, maganda dito. May F function din siya sa MATCAD. Then we will use 1,506.2 kN. Bakit? Kasi kung titingnan natin calculated base shear, it is more than with the maximum. So we will use the maximum base shear. And the ETABS calculation or calculated base shear, as you can see, the value is 1,505.4258 kN. And see, it's very minimal. And when we get the variance, so minus lang natin yan yung calculated base shear from the ETABS and divide natin sa manual calculation. And approximately we get 0.05% of the variance. Considering the difference between the base shear. And of course, for the FT value at the top, so we have a consideration here as per code. For the FT value, we have 0.07 times 7 T, the period and the base shear used. And we have here 66.79 kN. And for the FT max, we have here 0.25 base shear. But we have another, what do you call this? Reference and consideration. If T is less than 0.7 seconds, so we can say FT use is equal to 0 kN. So we will not consider the FT value at the top. And for the distributions of the lateral forces, so the formula here is like this. F, the forces at the specific level, the quantity base shear used minus the FT. So if FT is equal to 0, these automatically we will use the base shear multiplied by the weight of the structure at that specific level and the elevation. Okay. So kapag sabihin natin elevation, let's say this one. So in this level, the elevation is 4.2, and in this level it should be 4.2 plus 3.4. So elevation siya. Okay? That is 7.6. Let's go back to the distribution of the lateral forces here. So this is 0, and the denominator should be the summation of the product of each level of weight and the elevation. And to make it short here, I just separate it here and make it a variable na lang. So, itong gaganda sa MATCAD. You need to understand that in providing the equation or a value of a particular variable, you need to indicate colon and equals. Then, once you have already a value for that specific variable, just use equal. Then, meaning automatically, whatever the value of Wi, Hi, or the product of that one, if you introduce variable, then the next of that variable is equals. It's automatically calculated the previous variable which has been assigned. So ito, na-assign na kasi na yan eh. So ito yung magiging summation of the product of the weight and the elevation of its level. So mangyayari ito na. This is the base shear, this is 0, base shear, and we need to multiply it by the product of the weight of its level and the elevation divided by this value. Okay? So yan. This is the distribution of the forces, of the lateral forces. So meron tayong lateral forces, and the value in the ETABS model, in the ETABS software, is this one. And when I get the variance, it's very minimal. So negligible siya. As you can see here. And this is the distribution of the ETABS. See. Okay. Then I will show you here. So this is the model. Okay. So this is the model. Then I consider the beam and the perimeter and the parapet. Kasi mayroon siyang section dun sa given. Then in the mass source, I consider this one. Okay, 25% of the live load and 100% for the self-weight and the superimposed load. And for the load patterns here, we need to set up here an X, Y, and we will use only the XDR direction, X direction. So without the eccentricity factor, which is 5%. Then we have an option here. It's either by program calculation, but we will use the method A. So we will input 0.03. This is the English value for the 0.0731. And of course, AC seismic factor 0.4, and automatically it will calculate the CE and CV value. And of course the NE and NV, we need to modify it. NE and NV, and factor of safety, importance factor is 1.0, and overstrength factor is 8.5 as per the seismic building system. And of course the height, the tolerance, we need to set up that one. And it should be the same with the other direction, pero yung Y lang. Okay? And before that, we need to set the offset of the elements. For example, for the frame, here in the end length offset, we need to set at the 0. Here, like that. Okay. So that the intersection of its element should be included in the structure weight. So, but may option din tayo na is tanggalin siya, hindi siya include. Ayan. So after that, makikita natin yung result. Hindi siya nagkakalayo. So meaning, okay yung result ng natin. Manual calculation and the ETABS. Pero sa actual, of course, kailangan natin, madami pang i-consider dyan eh. Yung stiffness, yung eccentricity factor, yung diaphragm. And we let's go here in the report, show. And okay, this is the calculated result. The calculation. See, it's the same T and 12796 12796 12796. 12796C. It's the same. Not the same. There are discrepancies, but it is negligible. So you can neglect that one. That's for today, guys. Thank you for watching, and hoping you understand our discussion, and sana may natutunan kayo kahit paunti-unti, no? And by the way, I will be uploading this ETABS and the PDF documents sa mga natin, members from level 2 and level 3. Okay. Also the MatCAD file upload natin. Okay? Yun lang, guys. Thank you for watching, and don't forget to follow my page. So yes, I have also my page, Arts Engineering, Wiring Engineer, and my profile Facebook, Ruel Cepeda. And of course, in our YouTube channel, Arts Engineering. And by the way, I have also a TikTok account if you want to follow me. Just search Arts Engineering and Wiring Engineer. That's all for today, guys, and see you in my next tutorial. Thank you and God bless. Bye bye.